Bienvenidos, Hushamandid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the Spring 2021 semester. This is the CCNP ENCOR version 8 curriculum from Cisco Networking Academy. And in this supplemental video tutorial, we're going to be taking another deep dive look into IPsec site-to-site tunnels. However, instead of using crypto maps, we're going to be using static virtual tunnel interfaces, or SVTIs. And this video is going to again highlight the use with IKEv1 or IKEv1. The next video, which will be the last in this series on SVTIs and site-to-site IPsec virtual private networks, we're going to be setting up SVTIs and we'll be using IKEv2. So let's dive in and take a look at the topology that we're going to be working with. Again, if you've been watching the series and following along, you should be very familiar with what we have here. On the left-hand side, we have an office in California. On the right-hand side, we have an office in New York. And then we've got the ubiquitous internet service provider up here, which is that cloud that you could be traveling through to reach each destination. And so PCA right now is unable to ping across to PCB if we kick that off. And vice versa. You'll notice that PCB is unable to ping PCA, and that's because our static virtual tunnel interface between router 1 California and router 2 New York needs to be configured. Now, in the previous video, we looked at how we could accomplish this by using the default settings that exist. However, those default settings are not recommended. We took a look at the next generation encryption report or document that Cisco has produced that shows what we're supposed to be using when we can. And so let's go ahead and get this configured up. We're going to configure our phase 1 configuration first, that ISAMKP IKE phase 1. Again, we're using IKEv1, but this is the phase 1. This is the keying material, and we're going to be setting the parameters around which the shared secret keying information is going to be exchanged between these clients. And this is where you're going to hear Diffie-Hellman come into play, because it's Diffie-Hellman leveraging IKE, the internet key exchange, and we're leveraging Diffie-Hellman to protect that keying material that's going to give us our authentication in order to set up phase 1. So let's go ahead and say crypto ISAMKP policy. And on this side, we'll use policy 10. Now, as you've seen a couple times now, the steps here are going to look very similar to what we did when we were doing crypto maps, because we would still come in and still do the phase 1 configuration. And so we've got our, sorry about that, our authentication is going to be a pre-shared key. The encryption is going to be AES-256, right? And that's the best we can get with this version of iOS. The Diffie-Hellman group number, let's do a question mark. And you can see that in general, the larger the group number, the more secure it should be. And so we'll go with 24. Again, 21 uses the elliptical curve cryptography, and so that is also super effective, but we'll just go ahead and go with 24 here. Remember, 1, 2, and 5 you should not be using, and those should have not been used after 2012. You see it in a lot of documentation and in a lot of examples, but group 1, group 2, and group 5, those are legacy and those are to be avoided. Groups 14, 15, and 16, those are only good until 2030, and then you shouldn't be using those. So if you're setting something up greenfield, I would go with group 24 or group 21. So we'll choose Diffie-Hellman group 24. I could set the hash, and so let's go ahead and set the hash. And we want to set that to the SHA-512. Again, all things being equal, the more bits we have in the key, theoretically, the more secure the communication will be. Now, what else could we do here? We could tweak our lifetime between rekeying. Right now, it's 86,400 seconds, but let's cut that in half to 43,200 and make it 12 hours. And that's pretty much it, right? So if I was to say do show run, pipe it to section, ISAMKP, And here is what our phase 1 configuration looks like right now, but we're missing one command, right? So again, ISAMKP crypto, ISAMKP key, ABC123, and then the address of the other side. As I've pointed out numerous times, you could do quad zeros, but that would leave you open to a node that is not the node you're expecting to set this site-to-site point-to-point IPsec tunnel up with, trying to negotiate to set up a tunnel with you. So we're going to be very specific here, 209.165.20.222. Again, being specific is very, very important. And so that is our entire phase 1, our ISAMKP phase 1 configuration. We are done with that. And so now we'll move on to our transform set. And these will be the phase 2, the ISAMKP, and sometimes you'll hear IPsec because of the command that I'm about to run. You'll see crypto IPsec. And so a lot of people will say, oh, IPsec phase 2, because you're configuring the IPsec in phase 2. But there's nothing wrong with saying ISAMKP, IPsec phase 2, right? It's all about phase 2. That's what matters. As long as you get the phase 2 in there, you're good. And so we're going to go ahead and say transform set. I'll just say TFS to keep it simple. Now, here's where we've got a boatload of choices. And remember, esp-gcm. If I was to go back to that next generation encryption document, and we were to come up here to the top, you can see AES-GCM mode for authenticated encryption. And that is considered to be next-gen encryption. And we'll do 256-bit. And so hopefully that is going to be available to us. So let's change it up. We'll say ESP-GCM. So we're using the encapsulation security protocol. And sometimes I'll say payload for ESP, right? So ESP, that's one of IPsec's protocols. The other is authentication header. Again, authentication header, not too popular because it doesn't provide confidentiality, the C in the CIA. It provides integrity through the HMAC hashing algorithms to make sure that nothing's been changed in transit. But as we've discussed, that introduces challenges with NAT, because when we talk about those fields in the IP header, which authentication header is looking at, it's looking at the immutable fields, like the source and destination IP. NAT is going to break that. We're going to run into problems. And when you're a one-to-one scenario, that is what you would run into. It's even worse when we start to talk about port address translation. Remember, ESP and AH are layer 4 protocols, just like UDP or just like TCP, with one major difference. They don't have port numbers. So then how are you going to do PAT with ESP or AH? And again, let me reference this. And actually, I think we only have this is an IPsec document we were looking at earlier. So if I want to say RFC, I think it was 38. I can't remember. I think it was 3879, maybe? No, it's 3749 RFC for UDP ESP. 3948. There we go. And remember, this UDP encapsulation of IPsec ESP packets. Authentication header, because it is not as prevalent as ESP, due to the fact that authentication header doesn't support encryption. That's why this proposed standard only deals with ESP and IPsec. And so then this is how you can do NAT-T. So it's NAT-T or NAT traversal. All right. So again, off on a little tangent there, but good material to talk about again. So we're going to use ESP-GCM, and you can see 256 bits. And so this is going to be, excuse me, rock solid in terms of the configuration. And let's see here. If I was to use ESP-GCM, what if I was to say ESP-SHA? And I think it's built in, we'll say SHA-512, and then yeah, because it pulls out. So if we use ESP-GCM, it looks like it is going to cover us with that authentication as You can see authenticated encryption here. So it looks like that is going to cover us, and that's also next gen. We could have used just the regular AES mode for the encryption. Whoops. But we will go with the GCM. So, oops, sorry. Let me back out of here 1 second, and let's do that crypto IPsec transform set again with GCM 256. There we go. Now, remember, SVTI, static virtual tunnel interfaces, they're unicast and multicast only and must be tunnel mode, right? They've got to be in tunnel mode. And so it's convenient that that is the default. So you don't have to say mode tunnel. That's the default. All right, so that takes care of the transform set. So now what we're going to do is we're going to create a profile. So we're going to say crypto IPsec profile, and we'll just call it IPsec for IPsec profile. Now, it's in the profile, and this is where learners will say, well, yeah, we got rid of the crypto map, but we're still having to do sort of a crypto map style extra configuration step after the transform set. And that's true, but I think you'll appreciate that all you say is set transform set IPsec. That's it. We reference the transform set. And did I IPsec? And let's say do show run and include crypto. And maybe we've got a typo here. Oh, I said IPsec profile. I referenced I referenced the name of the IPsec profile instead of, I'm sitting there thinking to myself, oh yeah, that's the name of the transform set. No, the transform set was just TFS. So we create the IPsec profile, we set the transform set, and that's it, right? So we don't do the set peer, we don't do the match address, right? We don't put a description in here. And in fact, let me see, could we? Yeah, we could throw a description in here if we wanted to, but we're not going to do that. But we don't have those set commands and the match commands that we would have in the crypto map. So now that that is done, and we're going to do this entire configuration here on router 1, now we jump right into the tunnel, which is the configuration that we did before. Sorry about that. Let's say int tunnel 0. And so let's set the IP address of the tunnel up to 10.0.0.1. Make it a /24, 255, 255, 255.0, and then we're going to set the tunnel source to gig01. The tunnel destination is going to be the other publicly routable IP address on router 2 New York, 20.222. And then here's where we would drop in the tunnel mode commands, the 2 additional tunnel mode commands that we talked about. So it's tunnel mode, IPsec, and then IPv4, because we're doing IPv4. And then we reference the tunnel protection IPsec profile, right? And that profile, and here's where we're going to type in IPsec, right? Not the transform set here, it's the IPsec profile we created. And that's where we reference this. So you might look at this as like, yeah, it's definitely more straightforward, but that tunnel protection IPsec profile, kind of similar to coming in here and saying crypto map and then giving the name of the crypto map, right? So yeah, different, right? Easier to do. We don't have the crypto map. We don't have the ACL. So easier to do, fewer commands on, you know, in general, definitely fewer commands, definitely easier to deal with, and much more scalable. So we have tunnel protection, IPsec profile, IPsec, and we hit enter. And on this side, in terms of our ISAMKP phase 1 and the ISAMKP IPsec phase 2, we are done. It's all been done. The tunnel interface has been created. That static virtual tunnel interface has been created. And now any traffic that we route into this tunnel, remember, crypto maps are referred to as policy-based IPsec. When you're dealing with tunnels, it's routing-based IPsec. Because it's not policy that's getting the traffic into the tunnel, it's routing that's getting the traffic into the tunnel for us. So let's go ahead and type end, and we'll come back here, right? Because obviously, if you've been watching and paying attention, you know that there's going to be a routing protocol involved at some point, because right now PCA still can't ping B, and B still can't ping A. So let's get over to router 2, and let's get that sorted out. And here we go. And so let's go ahead and get our configuration done over here. So we'll go from user exec to privilege exec into global config, where we're going to say crypto ISAMKP policy, and I'll use different numbers to show you. This is a local value, that policy number. So we'll say 20 encryption AES 256 and authentication pre-share, and then we'll use group 24, and then the hash is going to be SHA-512. And I think we changed our lifetime to 43,200 seconds, or 12 hours, and we've seen what that looks like. So do show run, and then we'll say section ISAMKP. And let's see what we've got here for the phase 1 configuration settings that are going to protect that keying material, right? That shared secret that the symmetrics algorithm requires that we share. And then it's just going to be crypto ISAMKP key ABC 123 and address 209.165.10.111. And so there's all of our phase 1 configuration. Full stop. We're done. And so if the phase 1 is done, we know that we just need to do our phase 2. So we're going to say crypto IPsec and transform set TFS, and then we'll go ahead with AES-GCM here. Whoops, GCM, or ESP, sorry. esp-gcm. And 256. There we go. All right, we don't need to do mode tunnel because that's the default, but remember, static virtual tunnel interfaces must leverage tunnel mode. And so once that is done, we just come out and we say crypto IPsec profile, and profile, and we'll say IPsec P. And here I'll remember that when we're setting the transform set, that it's the transform set, not the name of the IPsec profile. And then we do our tunnel interface, and we're pretty much done. So let's get into int tunnel 0. We're going to say IP address 10.0.0.2. Whoops, sorry. Bumped into the enter key there. And then we're going to say tunnel source is going to be gig02. The tunnel destination is going to be 209.165.10.111. And let's make sure we get destination in there. So tunnel destination is 209.165.10.111. And then at this point, we've got our tunnel mode IPsec IPv4 command. And, oops, sorry, I forgot the mode. Tunnel mode IPsec IPv4. And then tunnel protection IPsec profile is going to be IPsec P, right? Case sensitive on that. So as soon as I hit enter here, we should have the tunnel come up. And you can see the state says it's changed to up. So let's go ahead and say show IP interface brief. Is the tunnel interface up? Now, remember, we're using ESP, and we're using IPsec. There is encapsulation that's taking place with tunnel mode. So maybe we also add in some additional settings on that tunnel interface. So let's get back in here. We didn't do this in the previous video, but we'll do it here. So MTU, let's set that to 1400. And let's also set the IP MSS. I'm trying to remember give me a second here. Oh boy. And I'm drawing a blank all of a sudden on the maximum segment size command. IP TCP MSS. Oops, sorry. TCP MSS, isn't it? Adjust MSS. There we go. All right. So this is typically 40 bytes less than the MTU. Because remember, the MTU is talking about the IP packet, right? The TCP, the segment size, right? When we say IP TCP adjust the maximum segment size, we're talking about the payload, layer 4, right, and above. And so we'll drop this down to 1360, which is 40 below what we're dealing with there. All right, so we'll save the config here. We'll do the same thing on router 1 as well. Again, just popped into my head that we didn't do that in the previous video. Again, focusing on getting the SVTI set up, but let's get it set up with some decent settings. IP MTU 1400 and then IP TCP adjust MSS 1360. All right, feeling a little bit better about that. If we go all the way out to privilege exec, let's see. Show IP interface brief. Is the tunnel up? It is up. Can I ping the other side? 10.0.0.2. Absolutely. Let's see what our phase 1 and phase 2 look like. Show crypto ISAMKP, and we'll just look at the security association here, and you can see we are QM idle mode, right? And so we're active, and phase 1 is complete. Now phase 1 is just going to kind of hang out until we have some rekey activity that might take place. And so then if I was to say show crypto IPsec, right, we want to take a look at the phase 2 security association. We see a little bit more information here. And you can see we even had some packets that we have encrypted and encapsulated, decapsulated, because those were those 5 ping packets that we had sent across as our test. All right, you can see the MTU, you can see the path MTU, the IP MTU setting, even though we've got it tweaked a little bit with our configuration settings. And let's see, what other interesting information? We've got the transform set information here, right? esp-gcm. And what else of interest is here? So that's pretty much it until we bring up the actual tunnel. So what does the interface look like? Show run int tunnel 0. So here is our current tunnel interface configuration. So things look pretty good there. So again, PCA and B can't ping each other because we don't have any routing information on router 1 California or router 2 New York. Well, let's change that, and we'll go ahead and run OSPF this time. So router OSPF 1, set the router ID to 0001 on this side. We'll say passive interface default, no passive interface tunnel 0, and then let's add our network statements in for the 10.0.0.1, and we'll lock that in with area 0, area 0, and then we'll add a network statement in for 192.168.10.0 as a /24 for area 0. All right, so now the configuration is completely done over on router 1. Let's go mimic that OSPF configuration over on router 2. So I'll say router OSPF 2 to prove that, again, that's a locally significant value in this use case. We'll set our router ID to 0002. We'll go ahead and say passive interface default. We'll say no passive interface tunnel 0. We'll add our network statement in first for the 192.168.20.0 subnet over here behind router 2, and we'll put that in area 0. And now this is the one that's going to start the fireworks and the OSPF adjacency between router 1 and router 2 over the static virtual tunnel interface. And as soon as that adjacency comes up over that tunnel interface, what we should see is router B can now magically ping router A, and router A can ping router B, and we have secured our communications between California and New York over a static virtual tunnel interface. And these routers now have routing information, show IP route OSPF. They now have routing information that they've learned via OSPF for the networks on either side. So if I was to add a network over here and say we'll hang it off of the switch here maybe, or off of the router here, into another switch and then out to another PC, and maybe this is the .30.0 network. All I'd have to do is add the network statement in here in the OSPF config on router 2, and off we go. No ACL to manipulate as part of a crypto map. We simply plug and play that new network into the OSPF config. It's advertised over the static virtual tunnel interface, and it's going to work auto-magically for us when we try to ping from PCA to what would be, we'll say, PCC over here, right? And so much more scalable. And this is when we're talking about scalability, right? Even with the crypto map, when we're talking about site-to-site, right, we're talking point-to-point, scalability really doesn't apply to, oh, well, you could scale like lots of point-to-points. It's, you know, it's going to be point-to-point no matter how you do it with what we're doing here, the SVTI. So the scalability is really all about when I start to add networks in. Because again, think about it. If we're using crypto maps, even if we're using GRE over IPsec, right? We get a little bit of a break, but there's still the ACL there. But if you're using just IPsec and the crypto map, you're going to have to start adding in all of the networks that you wish to communicate between these two sites. They have to be in there. And those ACLs have to mirror each other on both sides. All right, well, that is how you would set up the static virtual tunnel interface using IKEv1 with a custom ISAMKP IKE Phase 1 configuration and a custom ISAMKP IKE IPsec Phase 2 transform set configuration. And the final video that we're going to do is SVTI with IKEv2. And you're going to see there's no more main mode. There's no more aggressive mode. Those have all been replaced. And you're going to see that they're, it's not the child mode that I'm thinking of. Give me a second. It's going to pop into my head here. The create, no, it's not create child. The IKE SA init, sorry. So you're going to see IKE SA init messages. We'll talk about the 4 packets that go back and forth to make that happen. And instead of just the packets flying around, it's more of like a request response, almost like a TCP kind of a handshake that's taking place with IKEv2. And then there'll be this create child SA message as well. So fewer messages, right? And it's a little more streamlined, but the configuration of the Phase 1 and the Phase 2 is going to look a little different. All right, well, that is going to do it for this video and this evening. And hopefully you've got a much better feel as we've sort of walked our way from Cisco's first implementation of how to do site-to-site IPsec VPNs with crypto maps. Then we looked at the GRE over IPsec so that we could run a routing protocol that leverages multicast. Then we looked at the SVTI default configuration where we threw the crypto maps out the window and said, don't need those anymore. And in fact, had it up and running with maybe 7 or 8 lines of code. That was it over a tunnel interface. And then now we come in, we do some customization, and now we're going to move on to IKEv2, because if you're deploying this today, that's how you would want to do it, is SVTIs and using IKEv2. All right. Well, again, thanks for watching. Hope this is helping you out, and I hope to see you in the next video.